Just a second. Okay. Okay. Slides. Okay, so now, right. So welcome to day 4 afternoon session. Short info updates. We have Krasimir's talk start half an hour earlier on Monday, and we have an extra talk on Thursday. And to be updated on all of these and possible other things, it's good to subscribe to the summer school calendar. So if you haven't done it already, click on this plus. It's on the webpage. Okay, that was info. Now I'm going to talk about testing grammars. So what I've been doing since the morning session, I made, we were doing this construction pigeon language in the morning. And now that I have 3 hours of spare time, I extended a tiny bit. I can demonstrate how it works a bit. Are you watching, Nicholas? So this is this is obviously not, I kind of diverged from your corpus. I kind of started, I was getting more inspired about German, but like the core idea was the, sorry. Here. Yes, Nicholas, you're watching. Great. You're the inspiration for this grammar. So okay, so let me demonstrate the grammar. I've already compiled it into PGF. So and like the unwieldy name, because there's so many versions of this grammar already. So I'm just calling this const pigeon for testing. So let's generate some sentences. Do you come? Kommst du? You coming or not? And unfortunately, I can't really read this Chinese, except this is ni with some tone. But okay, so you can tell me at any point when you find bugs in one of the languages that I don't speak myself. Yeah, so we added some more nouns, more verbs. Let's make a command. So this is a bit diverging from the actual corpus. Like I just wanted to have something like something that made it different from the normal English. So I just added the word please completely randomly. So, and also I added imperatives for like plurals and third person. Yeah, so this is like the original command, like just play. And this was not the original, it was just my divergence. So now we have this quite complex grammar, and what we want to make sure that when we extend it, we don't break the original. So I'm going to start by making some unit tests, and then I'm going to talk a bit about GF test, which is my thesis project, which I haven't touched in 3 years. So like, but it's definitely still working. So let's start with the unit tests. I've created a directory already, so let's go there and do something. Unit tests slash. Yeah, so we can do this in many ways. So I want to create some tests for like each type of phrase. So I'm gonna do 3 files. I'm gonna call one equal.gfs, question.gfs, and command.gfs. And now we're starting to fill these with some content. testing unit tests. Yeah, let's start with the decals. So my inspiration is like I want to make sure that like all of these different constructions work. So I'm just like doing this completely manually. I'm thinking of an example and then I'm writing it down and I'm making sure that it outputs the thing I want it to. So let's do just declarative. So let's say that a simple test icon. Okay. Oh yeah, because I don't have the word I anymore. So that's why I removed it, because that was a bit difficult to make an imperative for. That's why. So okay, now I have this, and what I will input in the test file is this. So I'm going to preface. So I start the file by importing the grammar. Import once pigeon for testing.pgf. I'm using pgf because it's compiled already, and this grammar turned out to be a bit complex for German because of reasons. So if I just keep it compiled in this pgf, it's faster here. But you might as well, like, you could, if you wanted to do it for only one language, you could only, like, you could write this, it would be perfectly fine. Or like, you know, several, you could also do this if you only wanted 2 languages, for instance. But I'm just going to use the pgf. So then what we put here are GF commands. I showed this yesterday, so I can just recap. So GF -- run input will be then the unit test /decal.gfs. Oh yeah, and it's not, I'm not supposed to parse it, I'm supposed to linearize it. So, and when I do this GF command is run, and then it outputs this. And like what I would do, like, of course, I would independently verify all of them. And then if I accept, I would say, yeah, this is great. Then I would put it in a gold file. So decal.gfs.gold. So then I would, let's see, I would do the same for maybe commands. Let's import this again and do something like yeah, let's open this again so we get an idea of this. This actually, usually, like when you would do this, like you would take, what you would do is that you take some actual sentence that you want to model and then you put it there. So this is kind of like, it's not as optimal to do this like after the fact, but since I diverged from the original corpus, that's we're gonna have to do this in this kind of artificial way. Let's generate some random command. So generate random is often quite a decent way of kind of rough testing as well, but like obviously it's not as good as systematic testing. Let's do like this. Bank. Okay. There's this, and actually I kind of want to, like, now that I know, like I know that we have these different actors in this grammar, so I kind of want to do this for use singular, and like, you know, for German's sake, I also want to do it for you polite. And let's run this now. Echo, we run the command now. And here we get let the doctor walk, walk, walk. But then the German one has a difference here, like lauf and laufen Sie. Okay, so I'm happy with this. Okay, these were fine, so we'll put them in unit tests command GFS dot. And then let's do the same for the question. So import this. Generate some random question. Oh yeah. Oh, interesting. Actually, let's do some other verb again, like whatever. Let's do walk. Oh, we don't have that word, so let's just do them. Back. So, here's this. So now I have created these test files and the gold standard files. And now, of course, so I could have put them in the same files, all in the same files, but I just want to create some structure, like if the grammar grows a bit bigger in the future, so then it's like I know if I want to add a new thing, I can add it to one file instead of scrolling down 500 lines in one big file. And so then I usually include some kind of bash script. This is like extremely lazy. I could do it even nicer, where I would just have the name as a variable, but I'm usually extremely lazy and I always copy paste the same. So let's do the same here. That's what I usually do. So whatever I didn't, this is from some old random grammar where I had apparently stuff about queries and negations, but now I will have them about decol. I should change the naming scheme. So then I had command. And then I had one more thing, which was the question. And then I usually, so if there is no difference, suppose that I'm just going to change the grammar now because it's kind of takes a long time to compile for everything, but suppose we actually change the grammar instead of the output. So because then when we run sh, oh yeah, I call it unit test, not tests. That's fine. Paste. Call it unit tests. So now I can see that this is comparing, this is the output of the grammar and this is what's in the gold file. So it's telling me that there's something wrong. Sorry?
The line output is correct.
Yeah, I know. I just like I artificially changed the gold file just to so just to introduce an error. Now, if I do this and there is no error, then I usually output a line like this. It's just if this is the first line you see, it means success. So because all the errors go here. And then if I want to be super fancy, I can give it like an argument. I don't even usually like match the flags. I just say that if it gets arguments, then I'm gonna print out the stuff. So again, so tests, and then I would change these. These would be declarative sentences. And finally commands. This is like if I'm making an extra effort to be super fancy. Commands. So I can, you know, if I do like this, then people think that, wow, I'm so good at making command line flags, like verbose flag. But what I'm actually doing some typoing all over, so it doesn't work, but now it should work. Yeah, so. Oh, there's still some, oh, okay. This was the decal. Yeah. So this is my final, how I would use this test string, test script. So first I check that this is the first line I see, so it means success. There was the diff didn't, like here I'm running the diff. So step 1, diff against gold files. Step 2, if you are fancy, output the test the linearizations of the test trees. But this is optional, so again, if I just don't give it any other arguments, then I'll just I get the information I wanted that this works now. So I haven't when I changed the grammar, I didn't make the test cases fail. Okay, so this was unit tests, and next I'm going to, let's do something more advanced. But any questions of this part? So I will commit this. Oh, we have people. Nice. I'm not share my screen, so I can't see who's in the Zoom unless I check. So the more advanced way of testing is by using this was my previous slide, so I'm just gonna jump in % from like this slide. I think should work. Yes, so this is the situation that we just had. Like I manually maintain a bunch of test trees and their linearizations in several languages. This is just, this pizza is Italian, these pizzas are Italian in 3 languages. And afterwards, we take advantage of the fact that not all the languages have the same grammatical distinctions, and therefore they need fewer, like they need, some need more test cases, some need fewer test cases. So this is a program called GFTest, which takes a GF grammar compiled into PGF, one or more of one concrete language, and some function in the grammar, and then it generates a representative and minimal set of example sentences that use the function. So if we can do this for every function, a grammar has a finite amount of functions, so then we can do this for the whole grammar. So an example using foods grammar. We have tested here the function good. And for English, it gives us one test case. And this kind of makes sense because the linkat of quality in English is just a single, like it's a record with one string field. So we we kind of like, we know that that it doesn't change inflection form, it doesn't change place, like there is no other parameter there. Like we could have equally well chosen to give the sentence as these good wines or something else, but in that case that tree wouldn't have been minimal, so that's why I chose this. In contrast, but if we want to test that function good for Spanish, we get, so okay, first of all we get 4 test cases where it's predictive, because it inflects in number and gender, and that's why we need 4 different contexts to kind of tease out all the forms from it. So we need this wine, these wines, that pizza, and these pizzas. Okay, that was lexical functions. How do we test a function with arguments? So now we're testing mod, which takes a quality and a kind and returns a kind. So we, again, so the quality is always the same. The quality has its linearization, its linkat is just, again, like there is one string which never changes. But then for kind, it actually has 2 strings. It's pizza and pizzas in this case. So we get one tree, but that one tree is put in 2 contexts. And this is like rather minimal for this mod. We need to test that the tree that mod constructs will behave correctly when we put it in different contexts. For Spanish, a bit more complex. We have 4 trees and each of them is put into contexts. So here, why do we get these differences? Because cheese is masculine, pizza is feminine, that's an inherent thing. And then, okay, we get Italian as one of the adjectives, but then we get good. And why is that? It's because good has this inherent parameter about word order. So contrast this, queso italiano, pizza italiana, it's noun adjective. But here we have buona pizza. So pizza italiana or buona pizza. And actually this now reveals an error, which I'm sure will come on the next slide, but just. So yes. So these 8 test cases, 4 trees in 2 contexts each, reveal a bug in the grammar. So this is pretty good. Much better than ad hoc doing GR, because then you might have to do like, you have to do this GR, enter like 50 times before you might run into a bug, or maybe you never run into a bug because you get bored of it. So we found a bug. This is the wrong inflection form. So this is, it would be correct if we had if we had the like ese queso italiano es bueno, that would be fine because it's predicative, but we can't say ese bueno queso because it should be buen queso. So then another feature what GFTest can do is that it takes, we suppose we go and fix this grammar now. We have this bueno and we make it into buen when it's attributive. So it takes a new GF grammar and it takes the old, so it takes a new and old version and then it generates a difference between the grammars. So this is when we run the command. This is the diff command with GFTest. And then what it outputs is the new version says ese buen queso, and the old one is ese bueno queso, which is wrong. Exactly. So, okay, blah, blah, blah. This is probably not super interesting, but yeah. So that was that's basically the two use cases for GFTest. We create either representative set of functions, and then we can compare to two grammars. That was the slideshow. Any questions? I'll take probably like 10 more minutes-ish just to run GFTest on this construction pitching grammar. But any questions up until this? Okay. So now let's contrast this. Let's use GFTest. Oh yeah, by the way, if you wonder like, how do I install this great GFTest? It's on Grammatical Framework, GF on GitHub. Scroll, 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 or Control F, GFTest here. Updated 2 years ago, but you know, it's using Stack, so it doesn't bit rot. Here we have a bunch of table of contents installation. Yeah, you need to have the C runtime, but I think if you have the latest binary, you should have that already. But if you want to install this and you have any problems, ask me anywhere, like Discord, Telegram, IRC, email, send a pigeon. Like I will be very happy to help because this was my thesis software. I'm like very happy about users. Okay, so now let's run GFTest on these sentences. So sorry, on this grammar. So we take GFTest -G for grammar. So we're going to do the const pitching for testing. So I got the name. Language. So it needs a concrete language because the whole point is that it creates different set of test cases for different concrete languages. But we can give it also a list of languages if we want to create a test case for one of them and then just show translations in the other languages. So what I would do, if we just do S, S was the language code for this, like the original pigeon, which diverged from Nicholas's original. So we take that as the language we're generating it for. Then we can give it either a function. So let's see what would be a function. So for instance, okay, and it puts doctor in order to test this function. It puts it in one. It creates a one tree and puts it in one context. So that's not super exciting, but that's a lexical function, so that's expected. How about a syntactic function? So how about pred? Okay. Also one tree, one context. How about we do this for actual English? Okay, so this is actually, now we're getting a lot more tests. So in order to test pred, we need to give it 1, 2, 3, 4. It creates 4 trees, and then it puts each of them in 5 contexts. And that's how we can, according to this GF test, these 20 example sentences are a good test set. So let's see, are these correct? After reading these 20 sentences, we should be able to be much more confident that the English is correct compared to if we had just random generated 20 sentences. Okay, we play. Do we play? We have played. Have we played? Let's play. Okay, seems pretty good. Also, like, it seems like it doesn't seem redundant. Like, it seems like these are all like very different things. So like, I'm very happy to have seen these instead of just we play, for instance. Notice that we, oh yeah, right. So then we have, okay, we have you play. So you play, do you play, you have played, have you played, play. Yeah, I'm pretty happy that it shows me both like we and you, because for instance, like this is a very different construction. Like if I only had seen play, then I would be wondering like, how do you say imperative? How do you say a command for we? Okay, I understand this is how you say command for you, but how do you say it for we? So GF just does that. So yeah, now I know. And again, so these are the same, but here we have yet another construction for making commands. Let the doctor play. Okay, and here we have, so okay, so teacher and doctor. This is honestly, from my perspective, this as a human, I think it's a bit redundant to have both doctor and teacher, but I'm guessing that why GF test did it was because of this. When I chose the lexicon for WordNet, I put here teacher feminine as the first, but here it's just Dr. 1, and I think it's usually like the default is masculine. So I think GF test is recognizing that this is a feminine noun and this is a masculine noun, but that doesn't make a difference in this actual concrete syntax. So okay, so it wasn't perfect, but like up to like this was very useful to have we, you singular, and some third person noun. Okay, so what are we getting for German? Would we be happy to have these sentences for German? Like, is that all the grammatical distinctions that we can have? Well, no. So I'm gonna show the feature where I give it 2 arguments. It means generate the test cases for German, but show translations of them in English. Okay. Okay. Actually, let me open these in a file. So I'm going to write them into a file. So here's the file. It's org mode, so we can open it in Emacs. Let's take a new one. Question. Oh, okay, that it's not a question about this. Okay, so we remember for the pidgin, we had 1 sentence in 1 context. For English, we had 5 sentences in 4 contexts each. But 4 sentences, 5 contexts. And arguably, 2 of them were kind of redundant for this grammar, but they were there because 1 was feminine, 1 was masculine. If this grammar had included a reflexive, then it would have been absolutely necessary to test both, because then we would have had like the she sees herself and he sees himself. So that's a difference in inflection. Let's see. So du hast geschlafen. Du schläfst. Schlaf. Okay, so that's just 3. Du bist gekommen. Okay, so here is an example. For German, GF test finds that there's a difference between sleep and come, because in the perfect tense we have a different auxiliary. So du hast geschlafen and du bist gekommen. So that's why it is important to create a test case for these two. And also you can see this is kind of actually somewhat smart here. I mean, well, this is AI. I mean, yeah, anything is AI until we can do it. So, so this pred u singular sleep, pred u singular come, because these two would be the same because it's the same subject. Like I guess it would be du kommst and kom. So it doesn't repeat them because we know already from these two, like we have a good representative test case for the declarative and imperative. But it repeats, so it repeats the context of perfective, because that's where the difference lies. It's a difference auxiliary. Okay, so pretty happy with this. We sleep. Oh yeah, so this is again, it's a different test case because it's a different subject, and this makes total sense to repeat, because if we just see du hast geschlafen, we don't know if wir haben geschlafen is also correct or not. So we need to see this. It's a different string, so we need to have a context for that string, wir haben. And this is exactly the same same situation. We don't repeat the wir kommen and kommen wir. We just repeat the wir haben and wir sind. Next one. Oh yeah, so we're actually we're pretty boring here. We're just doing the sleep and come, but for all the different actors, because this is just about the agreement. Because polite to you again, here we have a different subject, so it's Sie haben. And finally we have the customer. So yeah, it's all the same sentences but different agreements. So that's why we have that. So now I kind of lost count how many that was, but it's like 4 basically. So 3 for a haben auxiliary and 1 for the sein auxiliary. So that's then, oh, that's 16, but it's because the English was redundant. So if we count 16 compared to, yeah, that was 15 then. So yeah, for the relevant cases, like, anyway, the point was that they were different sentences because they account for different grammatical phenomena. Yeah, I had opened these, like I had generated already like everything for all these sentences. So how about let's look at these. Oh. Sure, there's a command to do this, but so starting from the pigeon, we have 3 sentences for the whole grammar, because so everything in that grammar is just string concatenation. There is no parameters whatsoever. So that's why we get 3. That's 1 for command, 1 for declarative, 1 for question. So please customer pay for building. We pay for toilet already. Again, okay, I know this is not in the corpus, so sorry. we pay for toilet already or not. Like, I mean, I didn't make it generate toilet. It just, we added the word toilet in the lexicon and it just randomly chose it. So like the GF test has a sense of humor of a 5-year-old, maybe. I don't know why I chose building here and toilet here. It's random, I think. So three trees to test the pigeon. Next, so that's for the whole grammar. Because oh yeah, right. Maybe I should just show you one more useful flag. We use the flag F, which was test function. But we can also use the flag C to test category. So what it means, it goes through all the functions that generate something where the return type, like the result, is in that category. And then it just keeps those that make a difference. So we can do this. So this is only for commands. So we have again betale Lebensmittel. Not quite sure why these two are different. Could be because I made food into a mass noun. So probably the NP for food has a different, it's treated as different because it's a mass noun. Maybe it's such only in German or GL, maybe. Okay, yeah, looks reasonable. So that was just the command with the parameter, the flag C, in order to instead of just testing one category. So that was, yeah, 3 trees for the pigeon. Then what do we have for Chinese? How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So unfortunately, I can't really read any of this. So, but since I generated the English sentences, English translations, so apparently there is some distinction between let's buy a building and, oh, okay, no, there actually isn't. Oh, well, I think actually, yeah, it doesn't make it, doesn't matter. Let's buy a building. So we buy a building, we have bought a building. There is, the difference is this character here. So this must be some kind of perfective marker. So that's why these GF test gives me these 2 sentences. And do we buy a building? So we have a question with some question mark in here. Right, so yeah, makes sense. This looks reasonable. Like it's harder to judge if GF test did a good job if you don't know the language, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 trees. And each of them seems to be in one context. Yeah, that's often like the number of trees it generates, it kind of depends on the inherent parameters, and the number of contexts it generates is dependent on the variable parameters. That's kind of rule of thumb. So then for English, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's pay for flowers. We pay for flowers. You pay for flowers. Oh, wonder why that is different. The doctor pays for flowers. That makes sense because it's, again, different verb inflection. Oh yeah, right. Oh yeah, also like, actually, I do know why it's we and you different, because it's we and you have different, yeah. There is a difference, but it just doesn't make a difference in this grammar. So. All right, then we get this. We have paid for flowers. We have paid doctor, teacher. And then 2 questions. Yeah, this is actually pretty boring, to be honest. So let's get to the German one. This is now the exhaustive tests for the phrase. So let's pay for flowers. The client buys food. Yeah, I guess like flowers and food makes a difference because this is plural, maybe, not sure. Okay, I think maybe we can wrap this up. So that was seems to be working working for its purpose. And then now that you have these, like once if you generate these with GFTest, and then you could put these for each language as unit tests, and then you would like have again this test script like I had, and then when you change the grammar, you would run these unit tests instead. So that's like a bit more robust way of like acquiring good unit tests. So yeah, you can probably like write a script that takes this output and makes it into this GFS and gold file, but like yeah, any questions? I think we can wrap this up now. Want to say something? Or... Oh, I got more audience. Now you tell me I've been on mute this whole 47 minutes. Oh yeah, so actually now that I have more people, I can just quickly repeat what I was saying in the beginning. So share screen. So earlier start time for Krasimir's talk on Monday, extra talk on Thursday. Subscribe to the calendar so you get these updates automatically. That's it. Thank you. Oh, thanks, Ariana. Yeah, I actually like I use GFTest like all the time. I definitely eat my own dog food. It's like it's entertaining and also like it's not perfect. Like there are some kind of strange bugs there, but like it has very often like actually showed me that I was about to make a critical mistake, and then I run GFTest and I'm like, oh, I didn't commit it yet, so I'm gonna fix it now. Yeah, so yeah, if you want to come hang out at 8 p.m, I'll probably have the Zoom open, but like I don't have any agenda. It's just to hang out if you want to chat. So I'll be going home now. So bye bye.